When we are talking about the parametric equations of a plane, okay, we have to first of all consider about the vector equation of the plane. From the vector equation of the plane only, we can come up with the parametric equation of the plane. Okay, so when we are drawing a plane, when we are defining a plane, we normally say R equals to A plus lambda B plus mu C. Okay, so this is what we normally say. So if you want to visualize this, okay, if you want to visualize this, we have a plane, okay, we have a plane, and to visualize this perfectly, we have to draw the origin point, okay, we have to draw the origin point. There we have I, K, and J, okay, so this is the origin point. We will have a point A, okay, and the position vector of the point A will be the vector A as given in the vector equation. And then we will have two parallel vectors. Okay, we have two parallel vectors, and these vectors will have two directions. These vectors will have a specific value. Okay, so that's what we call the B vector and the C vector, the direction vectors. And for the value of lambda and the value of mu, you will have a specific point on the given plane. Okay, so let's say this is that specific point. So what happens is you have to go lambda times, mu times C and lambda times B to reach that point. Okay, so this is the point. So you will have to go mu times C. Okay, you have to go mu times C and then lambda times B. Okay, you will achieve and you will end up at the given point, and that point is given by the position vector R. So if you connect that point, okay, so if you connect that point, that is the position vector R. Okay, so that's what we call R. Okay, so here we can come up with the parametric equations easily. Okay, so when we were coming up with the parametric equation for the straight line, okay, we just wrote down x, y, z, okay, and then we wrote down the values, okay, given here. So let's write down the values for a, b, and c. So let's say a is given by x naught, y naught, and z naught. Let's say B is given by L, M, and N. And let's say C is given by P, Q, and S. P, Q, R. So we can't use R here. So I will go with X, Y, Z. Just X, Y, Z. Okay. So if you have values like this for the given vectors, okay, you can write down the parametric equation. Parametric equation will look like x naught plus lambda L plus mu x, and y will be equal to y naught plus lambda m plus mu y, and z will be equal to z naught plus lambda m plus mu z. So these are the parametric equations that we can use to several applications. When it comes to some different types of questions, we normally apply these parametric equations to come up with the answer. Okay, so let's do a question based on the parametric equations of the given plane. So we have to find the value of A. Okay, the A is given here such that P lies on plane phi, and phi is given by a specific vector equation. So what you have to do is, first of all, you have to come up with the set of parametric equations for phi. So that will look like x equals to 2 plus 4 lambda plus mu, and y will be equals to 4 plus lambda plus 4 over 3, and z will be equals to 2 plus 3 lambda, I forgot the mu here, plus 5 over 3 mu. Okay, so this is what we have. Now, since the point P lies on plane phi, okay, since the point P lies on plane phi, I can say x is equals to A and y is equals to 2 and z is equals to 3. Okay, so for the specific values of lambda and mu, P lies on plane. Okay, so let lambda is equal to S and mu is equals to t when p lies on plane phi. So now we can rewrite the system of equations. A equals to 2 plus 4 lambda plus mu. That is the first equation. And 2 will be equals to, you can't say lambda here, you have to say S and T. A, S, and 2 will be equals to 4 plus S plus 4 over 3T. So I'll multiply by 3, so that will give me 6 equals to 12 plus 3S plus 40. So that's the second equation. And we have 3 equals to 2 plus 3S plus 5 over 3T. I'll multiply everything by 3. So I will get 9 is equal to 6 plus 9S plus 5T. And that will be the third equation. Okay. From the second and third equation, you can find the value of S and T. Once you have done that, you can find the value of A. That's all you have to do. Okay. So let's do that. So here we have 3S plus 4T is equals to minus 6. And you have 9S plus 5T equals to 3. This is the second equation and this is the third equation. What I'm going to do is I'm going to multiply the second equation by minus 3. Okay, so that will give me minus 9s minus 12t is equal to 18. So let's say that is the fourth equation. And if I had the fourth equation and the third equation, I will get 0s minus 7t is equal to 21. So t is equal to minus 3. Okay, so I'm going to sub t is equal to minus 3 in the second equation. So that will give me 3s minus 12 equals to minus 6. So 3s is equal to 6. So s will be equal to 2. So I can substitute this value for the first equation. Sub s is equal to 2 and t equals to minus 3 in the first equation. So A will be equal to 2 plus 8 minus 3. So that will be equal to 7. So now we know A is equal to 7. Okay, A is equal to 7. So point P can be given as 7, 2, 3. So the vector OP can be given as 7, 2, and 3. That's all you have to do. So when you have to find if a point lies on the given plane, okay, if you want to check if a point lies on the given plane, what you have to do is you just have to come up with the parametric equation, okay, and then equate the values for the coordinates of the point, and if they work out perfectly, okay, you can come up with the answer. Okay, so this is all I wanted to talk about in the parametric equation. In the next video, we are going to talk about the scalar product form of a vector. Yeah, it's going to be interesting. After that, we will come up with the Cartesian equation and all. And yeah, after that, we will do important relationships. We'll learn about important relationships. So stay tuned.
For watching the 30th video in our vector series. If you found this explanation of the parametric equations of a plane helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist of master vectors and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.